You beat the arcade high score or finish an exhaustive 10-page essay only for the application to close unexpectedly and disappear. The technical cause of this frustration is simple. By default, software has total amnesia. Programs exist within a computer's RAM, temporary memory that wipes itself clean the second the power drops. To be useful, an application must bridge the gap between that temporary workspace and the permanent storage on your hard drive. Developers writing in Java use a specific toolkit to build this bridge, the FileInputOutput, or I/O, package. Mastering file I/O is the only way a developer can ensure their data survives after the power is cut, leaving a permanent record on the hard drive. Before data can be transported, the program needs a destination. We have to either locate an existing container on the hard drive or build a new one from scratch. Java handles this by deploying the file object. Think of it as a scout whose job is to map out the physical file system. The scout's first task is surveying the terrain. By using the exists method, the file object verifies if your target directory is already sitting where you expect it. If the spot is empty, the scout starts building. Calling the mkdir method creates a single folder, while the mkdirs method generates an entire tree of parent and child folders at once. The file object also inspects the rules of the destination. It calls methods like canRead and canWrite to ensure the program has permission to interact with that space. However, while the file object can find the destination and build the folders, it cannot move the actual data. To move the data, we open a stream. A stream is a continuous flow of information moving from the program into that waiting file. This diagram shows how Java organizes that flow. It splits streams into two distinct categories, depending on the payload being transported. The first path uses Byte Streams. Relying on classes like FileInputStream and FileOutputStream, this pipeline handles data in its rawest 8-bit form. Developers use Byte Streams for raw media. When copying an MP3 or an image file, the computer doesn't need to interpret the content. It just moves the raw ones and zeros from point A to point B. Byte streams are efficient for machine tasks, but they are useless if the output needs to be read by a human. Consider a different scenario, generating a financial report or a receipt. Here, the end user needs to actually read the file. This requires character streams. Classes like FileReader and FileWriter are designed specifically to translate and transport 16-bit Unicode text. To make that text presentable, we apply a tool called PrintWriter. It sits on top of the character streams and acts as a formatting layer. In this Code for PrintWriter test, you can see the tool in action. It turns abstract machine actions into a clear record for human eyes. To capture data as it is generated, we use standard streams, specifically System.in, which feed input directly from the user's physical keyboard into the pipeline. This hierarchical tree shows the scale of the Java File I/O toolkit. Descending from the root object level, these classes manage data transport, taking keyboard input, opening an output stream, and writing text via FileOutputStream, the backbone of modern software interaction. File I/O provides the infrastructure that cures a program's amnesia, turning fleeting data into permanent records.